All right, we're live. Now, for starters, when you're doing this, always sketch it on your CAS calculator. If you're not entirely sure, after sketching it, it might help. Minus 2x squared minus 8x minus 1. Now you sketch it on there and minus 2x squared minus 8x minus 1. Yes. All right, we sketch it there. Now, as you can see, this is like an archway of a door. And it says, the important thing is, though, you need to understand that the x-axis is the ground. Okay, the x-axis is the ground. State the coordinates where the front door meets the ground. So, in other words, we want to find... Shh, oi, please, keep it down. We want to find the x-intercepts. Now, when we sketch this, we go analyse graph and we go 0. We pick a point to the left. We pick a point to the right. We've got negative 3.87.
What do you think you can analyse graph there for?
0.
And then it's got like a little thingy. Where do I put that? It's got a dotted line. Where do I put the dotted line?
Just let me show you in a second, all right? Bring it over here. Bring it over here.
Bring it.
Bring your CAS calculator here.
Mine has.
Yes. Yes, please. All right. Now, you could do that. Now, the thing is it's saying state the coordinates of the point where it meets the ground. I would have accepted those coordinates there, negative 3.87, but also as well, we're solving for y equals 0. So what we could have done is we could have gone to menu. We could have gone to menu and menu 3.1 and solved for that. Now the thing is that when you sketch the graph, if we're after exact coordinates, the graphing screen is only going to show you in decimals. And a lot of the time we might not want you to go into decimals. So you pick a point to the left and you press the button. And then you pick a point to the right, and then you press the button, and then you repeat.
Okay, thank you. Oh, so it's meeting the ground on x. Okay.
Yes, exactly. So minus 2x squared, minus 8x, minus 1. Now we're solving for that equaling 0, comma x. Now look at this. This is what your calculator will give you. It'll give you an exact value, whereas your graph screen will show you coordinates which are in decimals. What I'm going to say to you is we haven't asked you to do to 2 decimal places. So can you please, I want the exact values, and your calculator has shown you that the exact values are negative root 14. It's pretty yucky looking.
Wait, but it says coordinates, like the other ones before going to the coordinates.
Yeah, but it gave you an approximate coordinate. It rounded off into decimal places. So what I would appreciate, and the reason why I say this is because in math methods, unless you're asked to round to decimal places, you need to give the exact value. And the only exact value is this one here, which is root 14 minus 4 on 2. Okay, so root 14 minus 4 on 2, comma 0. That is one of them. And then the other one is, now it doesn't have to be exactly that, it might look a little bit different. It's negative root 14 plus 4 on 2. 1 sec, root 14 plus 4 on 2. Now that, I want you to get in the habit of getting exact values, please. That's comma 0.
2-mark question.
Yeah, one answer, 1 mark for this coordinate,
Yep.
1 mark for this coordinate. Okay? But the thing is that if we ask you to round to 2 decimal places, do so, but we were asked for the coordinates. We didn't ask you to round. So that's the problem, is when you sketch this graph, when you sketch the graph here, and I go to control, if I go to there, those are not really exact. Your calculator's rounded off. Okay, so just be aware of that. Sebastian, you had a question. I make a point here, I'm going to make it here in the video. That is, in your exam, if you're asked to show something and you just give an answer, but you've been given the answer, we want you to show that we can complete the square for this thing here. By taking out minus 2 as a common factor, the same equation now looks like this. Complete the square and hence convert this equation to turning point form. In other words, we know that you can do it in your calculator, but if you haven't shown the logical steps between the answer and what we've asked you to do, then you will not get the marks because you can do it in your calculator. We know you can do that. But look, there's 3 marks associated with it, which means that we want to see 2 method marks. Okay? If you just go ahead and write the answer with a bunch of fluff, then you'll get 1 mark because we know that that 1 mark is for the answer for the calculator. But we want to see that you can do the work. So what I'm showing you is the correct method. Now, minus 2, square brackets, because everything's minus 2, we're completing the square inside the square brackets. If you don't use them, you're going to forget to multiply everything by minus 2 at the end. We're then halving, squaring and adding. So we're halving 4, which is 2. We're squaring it. We're then subtracting it from the same side, which is minus 2 squared, which is minus 4. And then we've got plus a half. Yeah. All right, so now what we need to do is we need to carry that through or simplify what's inside the brackets. So we've got minus 2 bracket x plus 2 all squared. Now, minus 4 is the same as minus 8 over 2. Minus 8 over 2 plus 1 over 2 is minus 7 over 2. So therefore we've got minus 7 over 2. Now what we do is we multiply everything. We're multiplying that and we're multiplying that. So what our result is we've got y is equal to minus 2 bracket x plus 2 squared. Minus 2 times negative 7 over 2 is going to be positive 7. Now that is our answer mark. And then I guess I wanted to see some evidence there that you have done it correctly and simplified, because we know if you did it in a calculator you would be able to get that. But remember, if it says show or use algebra, show or working, we want to see that you know the method to get those 3 marks. All right. State the highest vertical distance in metres from the ground to the peak of the door. In other words, we can go to here. Now, I want to probably go menu, Windows, zoom, and zoom out a little bit because there you go, I can see the peak now.
So it's only 1 mark.
It's only 1 mark, which means it's just the answer. So what we can do, though, is we go to menu, analyse graph, and that is exactly right, Max. We do not need to show an ounce of working because the answer in coordinates or just the answer is all we need. If it's 1 mark, unless it says show that, just the answer is suffice. So we go. We want to go to maximum. We want to pick a point to the left, to pick a point to the right, and look at that. I can even grab that and move it somewhere else. There you go. Negative 2,7 is the coordinate. Windows, zoom, zoom out. So state the highest vertical distance in metres. It is 7 metres.
So you just count it up. And so you're just assuming that each.
Yes, you've been told that in the question, that it's in metres. Now, the construction team decide to recenter the door, which can be modelled by the equation minus x squared plus 13x plus 4. So instead, what they're doing is they've got a graph which looks like this. Minus x squared plus 13 over 4. There you go. Now this is what the door looks like now. So it's then saying for 2 wires are connected at the door of the height of 5 over 2. Now a height at 5 over 2 means that y is 5 over 2. Okay, so what we need to do is we need to solve the equation 5 over 2 is minus negative x squared plus 13 over 4. Now we can solve it algebraically or we could solve it in our CAS. Now I'm going to show you how to solve it in the CAS first, because what we can do is we can go to here and we can go menu 3.1 and solve. and we're solving an equation. 5 over 2 is equal to, no, we want to press the arrow across, is equal to minus x squared plus 13 over 4. Now be careful, we need to solve with respect to x. So we go comma x and whooshka. Minus root 3 on 2 and plus root 3 on 2.
Wait, could you just bring up the...
So find the horizontal distance from the centre of the building to each of the two wires.
So would you just be able to bring up the calculator screen again, just so I saw what you put in?
We're solving the equation comma x. Okay? So basic, now look, we need to see some evidence. We need to see some evidence that there's working. So if I saw some evidence of this, you can't just write the answer because it's 2 marks. So what I wanted to see is 5 over 2 is equal to minus x squared plus 13 on 4. If you said to me, Cas solve gives you an answer of x equals plus or minus root 3 on 2, then that would be enough working that I've seen the method mark.
Would that be for every teacher though?
Yes. Yes. In an exam too, yes, absolutely. Find the horizontal distance from the centre of the building to each of the two wires. It's the centre of the building. So therefore, the horizontal distance from the centre of the building is what? No, it's not negative root. It's just root 3 on 2. Because it's from the centre of the building to each of the two wires. It's root 3 on 2 that way, root 3 on 2 that way. The centre of the building is this. Okay, the centre of the building is here. This distance there is root 3 on 2. That distance there is root 3 on 2. Okay, so you can see that that's what the question's asked us to answer. Now it says, for the equation in D, state the transformations that take place. What is the transformations that take place? There's 2 of them. What does the negative do? So it's a reflection in the x-axis. That is 1 mark. What is the other one? It's translated 13 on 4 units up. Make sense? 13 over 4. Yeah.
We know that.
Sorry? All right, so it says here, write an expression for the area of shop in terms of x. Well, the area it's a triangle, so it's a half times the base, 2x minus 6, times the height, which is x plus 2. Now, you might realise though that a half of 2x is x and a half of minus 6 is minus 3. So we actually can do more of the legwork here. That's going to simplify to that. Shh. Guys, we've got 4 or 5 minutes left. Let me just get through this, please. Shh. Write an expression in terms of x plus a, x minus b, where a and b are both positive integers. Isn't that, we've just done the work? Yeah, so hey, that's pretty straightforward.
Why do you get 2 marks on it?
Don't ask me why. Don't know. Left, guys. I want to finish this question off. So we've got 32 is equal to x minus 3x plus 2. 32 is equal to x minus 3x plus 2. Now you could go ahead and work it out. Now it says here we want the state the value of x exact form. In the form of this. So if I go to my calculator and I go to menu 3.1 and I go solve for that, 32 outside of, what was it, x minus 3x plus 2, x minus 3 x plus 2, and be careful, comma x, if your calculator's in the right mode, there you go. We've got two things. Now, you can see there that which one of these would you accept? Which? The second one, because that's a positive value. The other one's going to be a negative value. Okay, so therefore the answer is...
Do you add CAS-solve on your...
No, that's... Yeah, CAS-solve.
Yeah,
Yep, and then just write your answer. So therefore CAS-solve, and then from there you get x is equal to, was it 3 root 17 plus 1 over 2?
Yeah.
3 root 17 plus 1 over 2, which is in the format we required. Now, it says here, explain why both sections are similar. Why are they both similar? Because, yeah, so what you need to talk about is the angles being the same. So that would be 1 mark, as in referring to the angles. I don't have much time, but saying that is not going to be enough for 2 marks. That's 1 mark. You then need to say, you could maybe label it. You could maybe label it as, let's say, B, C and D, and you could say that angle BCD is shared, and then you could say that angle CBD is corresponding to the one. That's right. So that's how you get the other mark. All right, you need to actually prove it. There's no way that's going to get you 2 marks, is it? Okay, but I'm going to just fly through that. Given that the back section of is 4 metres wide and has an area of 13 square metres. Now this one is no longer examinable. We didn't really cover this, but you guys might recall. Actually, I don't even think you have seen that. That is that. Remember how we have the scale factor? What happens is that...
Let's not worry about it.
Wouldn't worry about that one, please.
Wait, are we coming back and we're entering next class?
Yes, we're going to